Hello everyone and welcome to my channel. My name is Dr. Korachi, and in this video lecture we're going to talk about programming for security professionals. Now, in this video lecture, we're going to talk about the basic fundamental of programming concepts. We're going to talk about HTML from security point of view. We're going to talk about parallel programming also from security point of view. We're going to talk about the weaknesses and strengths, and including object-oriented programming and Python programs from us again from security point of view. Now, this is not a programming class, but we will look at the security issues related to some programming languages. Now, first of all, computer programs. You must understand the rules of programming languages, So every programming language have very specific rules and structures, often referred to as the language syntax and semantics, that govern how programs written in the language, behave. Now, mastery of these rules is imperative for developing software that functions correctly and efficiently. Frankly, a programmer who fails to understand these ideas will find it difficult to implement algorithms or even execute simple code. Now, when, dealing with syntax errors, you need to handle syntax errors effectively. This is a critical skill for any programmer, as these errors prevent the code from being executed and need to be resolved for further development and testing. Now, one minor mistake in your code and the program will not run. For example, like those logical errors can make a program behave unpredictably or produce incorrect output, making them harder to detect and rectify. Now, being a good programmer involves not just understanding the syntax and rules of programming language, but also best practices, design patterns, and the problem domain. Patience is key, as debugging and problem solving are, a very important part of the development process. Programmers often have to spend a lot of time isolating issues, identifying optimal solution, and then refining their code. Now, let's look at the fundamental concept for branching. Like, branching allows for conditional execution of code segments by enabling the program to make decisions based on conditions, such as if, and else statements are typical examples of branching. Now, looping enables the repetition of code blocks, which is crucial for tasks requiring repetitive operation. Example used in these type of program languages: for, while, and do while loops. Loops are crucial for tasks that require repetitive operation, very important part. Now, for testing here, testing involves validating that the software behaves as expected, ranging from unit tests for individual components to even more complex system level tests. Now, what is algorithm? Algorithm is a set of well-defined steps designed to perform a specific task. Simplicity is the key for both ease of implementation and understanding. Now, forgetting a step can lead to issues, potentially causing the algorithm to produce incorrect results or fail altogether. A bug, we know the bug that means, there's something wrong with your code and will cause unpredictable results. Now, pseudocode, it's a high level, human readable description of algorithm or a system's functionality, written without the strict, syntactic rules associated with the programming languages. It's very simple. It helps you to create the structure of your program before the actual coding. Now, documenting your work is essential. Yeah, obviously for several reasons. I mean, some of the reasons are maintainability, collaboration, and compliance are crucial software development aspects significantly enhanced by effective documentation. Now, proper documentation simplifies code maintenance by making it easier to understand and debug. It fosters collaboration by acting as a communication medium among, all these team members, aiding in a quick onboarding and encouraging external contributions. Additionally, comprehensive documentation is essential for meeting regulatory requirements, providing an audit trail, and ensuring accountability, thereby serving as a cornerstones for legal and cybersecurity compliances. Now, according to the industry standard, they're saying there's a 10 bucks for every 1,000 lines of code. Now, for example, like imagine this. Windows 10 contains over 50 million lines of code, but it has a fewer bugs than average, or comparing to those previous versions of Windows. Now, Windows 11 is most likely to have even more lines of code than Windows 10. Why? Well, because it includes a number of new features and improvements. However, Microsoft never disclosed the exact number of line code for both Windows 10 and Windows 11. Now, let's look at the first language, which is C language. It was developed back in 1972. It's very powerful language. By the way, Unix was first written in assembly language. Later, it was rewritten in C language. You know, C programming language is a popular choice for cybersecurity professionals because it is a low-level language that gives programmers direct access to memory and system resources. This makes C ideal for developing security tools and applications that need to be fast, efficient, and reliable. Now, C language in cybersecurity. Let's look at malware analysis. C can be used to develop malware analysis tools, that can disassemble and inspect malware to understand its behavior and how it works. Now, when it comes to vulnerability research, C can be used to develop vulnerability scanners and other tools that can be used to identify security vulnerabilities in the software and systems. Now, here's the problem. For exploit development, it can be used to develop exploits that can exploit vulnerabilities in a software. For security tool development, C is used to develop a wide range of security tools, like firewalls, IDS, IPS, and even encryption algorithm as well. Now, C++ language, this is an enhancement of C language, and it has almost the same features. Now, compiler. Now, it's a program that converts text-based program called source code into executable or binary code. C++ compiler is designed for developing application. Most of the C compilers can also create executable programs in C++. Now, what is the role of compilers? Compilers check for syntax error, type mismatches, and other issues that would prevent the code from running correctly. Modern C++ compilers have various levels of optimization that aim to improve the efficiency of the generated code. Also, concerning debugging information, while generating the object code, compilers can also embed debugging information within it, which aids in debugging the program later. Now, let's look at the consideration for cybersecurity professional, when it comes to strength and weakness here. Like for strengths, C++ offer high performance, ideal for real-time cybersecurity application like IDS. It is low-level access capability. Okay, are an advantage for memory analysis and packet sniffing tasks. It's a wealth of libraries and framework in C++ focus on securing code and encryption. You can find plenty of libraries and, outside, online. Now, when it comes to weaknesses, the language's complexity can be a security risk. Mainly features like, pointers and manual memory management, it can be an issue. It is also prone to buffer overflow and memory leakage, which is a very common type of attacks. Now, older system written in C++ may lack modern security features. Now, there is another consideration also, like for securing coding, practices, knowing the C++ weak points can help you as a security expert, to identify vulnerabilities in existing systems and also guide developers in writing more secure C++ code by adhering to best practices. Now, as a pen tester, you need to understand C++, which can be highly beneficial for, ethical hacking activities like pen testing, especially for finding vulnerabilities in native application or system written in C++. Now, as a digital forensics specialist, C++ can be employed to develop specialized tools for digital forensics, such as data recovery analysis tools that work at the low level to extract maximum information here. Now, if you look at this table here, we have, there are different type of compilers, Intel compilers for Windows and Linux, the Microsoft Visual C++ compiler, and this is widely used by programmers developing C and C++ application for Windows platform, for example, And there's like also these free compilers can be downloaded for Windows and Unix platform. Now, let's try to understand HTML basics. HTML is a markup language. HTML itself is not a programming language and does not possess the complexity of languages, like C++ or Python. Mainly used for web page formatting and layout, and the basic HTML syntax is the basis for web development. Now, for security professionals often need to examine the source code of the web pages, and they need to be able to understand and figure out when something looks suspicious. Now, let's look at HTML from security perspective, from strength, simplicity, and ambiguity. Now, HTML is straightforward to understand and use. Okay, honestly, but making them, making the process of securing HTML-based applications somewhat more straightforward than more complex languages like C++ and others. Now, for client-side rendering here, HTML content is primarily rendered on the client side. While this does not improve security directly, it does mean that the server-side resources are not tied up in the content rendering, allowing for server-side security mechanism to be more robustly implemented. Now, for weakness, susceptibility to injection attacks, HTML is often susceptible to code injection attacks like a cross-site scripting. Now, for third-party content risk, imagine this insertion of a third-party content, because HTML allows for easy insertion of a third-party content like scripts, images, etc., which can introduce vulnerabilities if those third-party sources are not secure. Now, this opens up avenue for different type of attacks, especially man-in-the-middle attacks. Now, it has extremely limited security feature. It lacks built-in mechanism for data confidentiality and integrity. Now, therefore, for secure data transmission, reliance on other technologies like HTTPS is very important. Now, okay, so now we know about the strengths and the weaknesses. Now, what is the consideration for you as a cybersecurity professional? Things you need to keep in mind: input validation and sanitization. You know, you need to focus on input validation and output encoding to prevent attacks like XSS. Proper input sanitization can remove malicious code before it has the chance to execute. Okay, another thing for secure configuration here. Ensure that the HTML pages are configured, okay, to enforce security policies like content security policies, CSP, to prevent content loading from unauthorized resources or mistakes. Now, creating a web page with HTML is so easy, so simple. You could like start it, by opening Notepad, and then whatever code you enter, you could, you could see it in a web browser. Now, HTML does not use branching or looping or testing whatsoever. See, this, these symbols here will define the HTML tags. And of course, like if you open this HTML tag, you need to close it at the end. Now, let's look at some of those HTML formatting tags and what potential risk that comes with it. The first one is the script. Now, this tag is used to embed JavaScript code within HTML document. It is a major vector for cross-site scripting attacks if not properly sanitized. Iframe also can be used to embed content from another web page sites, posing risks such as clickjacking if not configured correctly, with the proper security headers like xframe-options. Image, we know image is used for embedding images, but also can be abused for various attacks, such as loading content from malicious sources or used in a way to trigger errors for exploitation. Now, also we have the form. This tag is used to create HTML form and is prone to cross-site forgery. Input and text area. Input fields are another area where data can be injected. Again, improper handling of these fields can lead to vulnerabilities like stored XSS, because you're inputting here. Now, object here, this tag allows for, embedding of external resources, and that's really can be serious. If those external resources are compromised. Embedded, similar to object, this tag embeds external content like Flash videos and can be vector for attacks if the external content is malicious. Now, it is important for you to know that these tags are not inherently dangerous. However, attackers can use these tags to inject malicious code into your website, causing additional problems to you and to your and of course your clients if it's not programmed correctly. So, therefore, it is important only to use these tags from a trusted source and to carefully review any source code you embed into the website you want to use it. Now, what type of security consideration for you as a cybersecurity professional? The first one is data sanitization. All input and attributes should be properly sanitized to prevent injection attacks. Content security policy needs to be implemented to restrict the sources of scripts, frames, and other content. Another thing, the attribute whitelisting only allow a set of safe attributes and tags to be rendered, rejecting all others as a part of sanitization process. Now, another important thing here, the security headers. Use, for example, HTTP headers like xcontent-type-options and X-frame-options to add extra layers of security. Now let's take a look at the Perl language. Perl means practical extraction and report language. It's what developed by Larry Wall in 1987. It can run on almost any platform. You know, even Linux-based operating system, they have already Perl installed. Similar to C, in reference to syntax, very powerful scripting language used to write scripts and programs for security professionals, a popular language for some security professionals, and it can run on multiple platforms without significant modification, which means it is beneficial for cross-platform security solution. Now, let's take a look at the strengths and the weaknesses for this language. The first one here, you have the string and regular expression handling. Now, Perl excel at text manipulation and regular expression operation. This makes it well suited for tasks like log analysis, data extraction, and other operations related to cyber forensics. Now, for scripting capability, it's excellent for writing quick and powerful scripts. Very useful for automating tasks like network scanning, file integrity checking, and data processing in cybersecurity. Cross-platform compatibility, you know, well, we know that it's highly portable and run on variety of operating system. This is advantage for security solutions that need to be platform common and easy to install in different platforms. It has an extensive libraries, offers plenty of libraries that can aid in tasks ranging from cryptographic operation to network communication. Now, the weakness, readability and mintability. I mean, it allows for more than one way to accomplish tasks, leading to potentially obscure and hard to read code. This can pose a challenge for code audits. Now, for performance, while this language is excellent for scripting and text manipulation, it may not be performant as compiled languages like C or C++ for some tasks, like, high-speed packet analysis. It has limited web frameworks, not as extensive as frequently updated or, like in other languages like Python or Ruby. Unsafe operations, this language allows for operation that can potentially be unsafe, like direct shell access and system calls, which can be exploited if the code is not carefully written. Complexity is another issue. Now, we know that Perl's rich feature set and flexibility can lead to complex constructs that are hard to understand, analyze, and secure effectively. Now, let's take a look at the object-oriented programming, a very common, very well-known programming model, which based on the concept of objects. When encapsulation a code or data, and the functionality that operate on them. That's what object means. Now, the OOP provides several features such as inheritance, polymorphism, and encapsulation. Now we're gonna look at each one of them, understand, what does it do and what type of security implication with it. The first one is the inheritance. It means that the subclass inherits attributes and the behaviors, such as variables and methods from the existing class, which is known as superclass. The primary purpose of inheritance is basically to promote code reusability, make it easier for programmers, and to establish relationship between the parent and the child classes. Now, what are the security implications? Now, code reusability. Now, the reusability makes it easy to reuse the code, which leading to more consistent and easier to manage security features. Now, but it could inherit vulnerabilities, like in case incorrectly implemented inheritance can introduce security vulnerabilities by exposing sensitive methods or data. Now, Polymorphism refers to the ability of different objects to be treated as an object of a common superclass. What's the security implications? Code integrity. Well implemented polymorphism can make the code base more flexible and easier to understand, making it easier to implement security patches and updates. Now, the issue here, it could have unintended behaviors. If not implemented correctly, you know, polymorphism can lead to unintended behaviors, creating potential vulnerabilities. Now, let's take a look at the encapsulation. It means the bundling of data, variables, and methods, functions that operate on the data into a single unit called the object. It restricts direct access to some of the object's components, making it possible to hide the internal state of the object and requiring all interaction to be performed through an object's method. Okay, so what is the security implication? Data hiding. Encapsulation can protect the integrity of the object data by only allowing it to be changed in well-defined ways you define it as a programmer. Access control. Through the use of access specifiers like, such as the private, protected, and public, encapsulation can control the accessibility of the member variables and methods. So in this case, we can have better controlling against any unauthorized data access. Now, risk of false sense of security, poor understanding or implementation of encapsulation features can lead to a false sense of security. I encourage you to read more about the security implication and understand the strength and the weakness of object-oriented language. Now, let's take a quick look at Python. Python is a scripting language with some object-oriented features. Emphasize code readability and use indentation to define blocks of code. It runs on almost any platform, including Windows and the Linux-based operating system. Usually have Python already installed. Now, next, we'll take a look at the security strength and the weakness in Python. Okay, so like any another programming language, Python has its own strengths and weaknesses. So we're gonna look at just some of them. The first one, ease of use and readability. Python's syntax is clean and easy to understand, which allows for quick prototyping and development of cybersecurity tools. Now, this is essential for responding to security incidents promptly. Now, rich standard library. Python's extensive standard library allows for easy implementation of tasks, such as network scanning, packet sniffing, and these are common application in cybersecurity. Data analysis and machine learning. Okay, Python is a leading language in data science and machine learning, which is a lot of things are relevant to cybersecurity, such as task, for example, like the things we discussed before, anomaly detection and predictive analysis. Flexibility, Python, a wide range of application, they have from web development to data analysis, makes it a flexible tool in cybersecurity experts toolkit. For example, Python can be used for both offensive security like pen testing and defensive security like IDS. Now, the weaknesses. So, the first one is the performance. Being an interpreted language, Python is generally slower compared to compiled languages like C. This could be a limitation in real-time processing scenarios, such as high-speed packet filtering or IDS. Now, for memory conception, see, Python's case, Python ease of use often comes at the cost of higher memory consumption, which can be an issue in a resource-constrained environment. Now, threading limitation. The Python's global interpreter lock GIL is often cited as a drawback for multi-threaded application, potentially affecting the performance of certain types of security tools that require high, concurrence. Obfuscation and reverse engineering, Python could be an easily decompiled, making it easier, to do reverse engineering. Now, this is an advantage if you are developing a proprietary security algorithm or tools. Lack of low-level access. Python abstracts many low-level operations, which could be a limitation when you need fine-grained control over the system for tasks like custom packet assembly or direct memory manipulation. However, Python offers a lot of advantages for cybersecurity professionals due to many features I discussed, including ease of use, extensive libraries, and community support as well. However, its performance limitation and other weaknesses need to be carefully considered depending on a specific use case. Now let's look at Ruby. Ruby, it's an object-oriented language used by many security testers. It's pretty much similar to Perl language. Now, Metasploit, a Ruby-based program used by many security testers and used for, to check for vulnerabilities in computer system. That's why it is also recommended, for you as a security tester to understand the basic of Ruby and to modify Ruby code if needed. Now, let's look at the strength. The first thing, the Metasploit framework, one of Ruby's most significant contributions to cybersecurity is the Metasploit framework. It is a powerful tool for penetration testing and vulnerability identification. Now, expressive syntax, Ruby's syntax is clean and expressive, allowing for a quick development of cybersecurity tools. Object-oriented design. Ruby's strong object-oriented features make it easier to create modular and maintainable code, which is essential for large and complex cybersecurity projects also. Dynamic nature. Ruby's dynamic capabilities, such as meta programming, can be leveraged for specialized cybersecurity tasks, including like creating what's so-called domain-specific languages, DSLs, for specific security operation. Rich standard library, and it has a very comprehensive standard library and a rich ecosystem of third-party libraries, providing a variety of functionalities relevant to cybersecurity, such as encryption, network protocols, and data serialization. Now the weaknesses. Performance-wise, it is slower than compiled language, like comparing to C or C++. Now, this can be a limitation in scenarios requiring real-time processing, such as IDS or high-speed network monitoring. They require intensive memory and resources for this. Now, the memory consumption, there you go. Robbie's garbage collected environment can result in higher memory usage, which can be a drawback, again, in resource-constrained settings or application. Obfuscation and reverse engineering, pretty much similar to what I discussed in Python. Complexity, Ruby is flexible, okay? And the ability to accomplish tasks in multiple ways can lead to complex and hard to maintain code. Now, this could introduce vulnerabilities if not managed carefully. Now, finally, we did discuss the basic fundamental programming concept. We talked about HTML from security point of view, and we talk also about Perl's program weaknesses and strengths from a security perspective, including object-oriented and Python, also from security point of view. Now, the main focus, as I stated at the beginning, is not to teach programming, it's just to give you an idea about the weakness and the strength for each common and famous programming languages. And finally, I want to say thank you so much for listening to this lecture. I hope you like it, and thank you again.